Okay, so this is the design attached. As you can see, it's a completely different design. Um, so each finger has equidistance from the thumb, except this one I'm reprinting that right now, as you can see here. See that? So it's a little bit bigger, it's got a little bit bigger hole, and it's going to have room for all the circuitry that'll be done onto the faceplate, which was something that I got into with this design. So as you can see here, let's see here, see the circuit board is a panel that just pops in, although this is going to be wire on the first version. As you can see here, this does, wait, let me take this off. As you can see from my previous tests, this does actually work. See, so the pressure sensors do work, and so this one is going to be like that, in that there will be a plate that will pop into this part here. This was just a mock-up so that I could get an idea of where everything is. It's very, I don't know, even to me it's a very interesting design. I don't really know how these things are going to work out until I make them, and so you can see it's a very interesting design. From here, this is in the process of being angled, because the thumb actually comes at it like this and not straight in. So I'm angling this up, like coming out up like that, and these will be a little bit more raised because the sensors will be here and here and here, and everything will junction out into the circuit board plate that'll fit on there. And so you can see that the action is completely different. Even though the hand mounting system is the same. Okay, so this solves a very significant question. This panel will fit into here. See, this is the hand unit. Now, this is the mock-up of the hand unit. You can see the basic size of it. See, this panel here pops right into there. So the battery's underneath here, and there's two posts that come up, and they connect with the bottom side of this, where all the power regulation is, right? So and then that's routed to all the sensors, which will be in this configuration, the same as the little LED mock-up that I made to test whether or not this is the accelerometer. I decided to play with the Adafruit accelerometers this time. I'm just curious. I've ordered a few off of eBay that cost $2 each. So that takes the total cost of everything once it's completed from $80 down to about $50. So that's the sweet point of being able to build this thing. So this is the original. It's actually the right hand, but I can't find the left hand, so we'll just use this. And this was the base model idea. Then I decided to make the mounting down in the corner, so that when it's mounted to the hand, the thumb goes in here straight, so I don't have to like bend my finger. You can see the thumb actually comes at an angle, so that's the natural position right there. So, but the hole was kind of like that, so that was not working out very well, but it gave me a chance to go ahead and get something that was mounted to my hand, so that I could go ahead and get that worked out. So we'll just stack that real quick. Now, this was the one where I actually did angle. You can see the hole is actually angled upward. This was just a mock-up, just to get an idea. There's the battery slot in the back, and I I covered that hole, but then I realized I can uncover that hole, put something in that hole like lights, and I don't have to, that'll be an extra space to put something. So it's it's very minimal-ish. Now I noticed that when I'd hold it, my fingers would kind of slip around a bit on this end over here, and there wasn't anything really telling my thumb where it was. Even though I have a good sense of where my thumb is, I felt like I needed some guides since my thumb is the joystick. My fingers are the joystick. That's one, right? So to reopen that, to put a place for a capacitor here, and to put finger grooves, and to go ahead and put in the slots for the sensing pieces. I won't call them sensors since the whole thing is a sensor, but I'll say sensing elements. Let's call it that, right? So this is the last one so far. So as you can see, this one has evolved quite a bit. There is the hole for the supercapacitor that goes down in there further. I'll probably have to scrape that out a little bit. It printed so clean, but it took forever. This thing took like about 5 hours to print, but the quality is beautiful. Okay, so this is going to be the sticking point here. I can tell. This is the ESP8266. I've got it running into this this little FTDI thing that allows it to go into the COM ports in the computer. That's how I'm programming it, so that I can put it into the system. This, I've discovered, is the point that is going to hang me up. I have to get this to act like the previous radio, which is this. This is the RNXV. This is what I've been using for the last couple of years. When I went Wi-Fi, I went with this module, and other than its low power capability, it's only 12 dB, it has performed amazingly. And I remember this one, I had it for a year before I even programmed it, but when I did program it, I just didn't want to use anything else, and it has been beautiful, but it cost $35, and so that's not a very scalable vector for an open source project. Whereas this one, let me zoom. Okay, so whereas this one costs $2.50, and I've got a whole. Wait a second. Let me zoom this in a little bit. So I've got loads of these. I've got multiple types because they're so inexpensive. This is so this is these are the ESP ones. I think these are 12s. Basically, it's the same thing as the ESP8266 Wi-Fi chip, which is that chip right there. So it's the same on every one. This one is FCC compliant, for whatever that means, and a little bit more power, a lot more pinouts. It's labeled. Still, $3. So, and 4 megs of RAM. So these are going to allow me to really stretch out. They're programmable with the Arduino IDE, with Eclipse, with it's an amazing Wi-Fi platform.
What the natural rate is. So for 1 megabyte blocks, you need networking bandwidth of much more than 1 megabyte per 10 minutes. Otherwise, you can never catch up. So imagine as a network, as a blockchain.
Okay, so there it is. That's the frame. These are the sensors, as you can see. See, when I have another piece, let's use that for an example, that will contact these two together. So those are there in the thumb hole, along the outside edge, and in a little array in there here in the index finger area. That's going to have to be tweaked quite a bit to make that proper, but for the time being that shit works, so I'm done. And then there's the battery, and these are little holes that'll hold the Ninja Flex key on, so you can see that's how my fingers, actually it'd probably be better, see there's the thumb, that'll go there, so there'll be a little array there. I had to change this to put this more towards the outside so that it's closer to here. Like I said before, this was the relationship that I needed to get to, which is the pinky and the thumb. Those are the only two fingers that actually contact the thumb, contact together head on. And I wanted those to be right. Okay, so we've reached the point of wiring the sensors. I was going to print the internals the same way that I printed the other ones, but I have some stuff to do by this coming Friday. Let me turn this down a little bit. I have to present this thing on Friday, which is about 5 days from now. I do not have time to troubleshoot that, and this conductive material does not really it's for sensors like the ones that I have here, that's one thing, but for getting the juice from the battery, which is here on the back, that is something else entirely. So what I did was I made these little contact tips on the ends there, but I put a piece of wire through them, and those are contacting a metal bolt with all the wires connected to it. So these are conductive, but that's not conducting the electricity. There's a wire that's conducting it through both of those. And so now I'm getting the full power of the battery coming out to all of these wires, and each of those terminates in a sensor. And that's, you know, the cathode and the anode. And in a moment I'm going to wire up the the little Atmega chip to all the cathodes, so that when I connect it, it pulls it down so that there's not a lot of noise that it's sending out, because if it was just pin and anode, I'd be getting a fluctuating signal, whereas this way it pulls it down, and so then when I press, it'll send a very clean signal. I've started adding LEDs. See, that's one. These LEDs are different. They actually have a common anode, which means that when nothing else is going on, they're on. And when I turn this system on, my previous ones would turn off no matter what. These, as soon as I turn this on, you can see, boom, that joint just lights up right away. You can also see that right now I'm just tentatively using the Arduino that I was using in the previous system. I'll be getting some Pro Minis tomorrow. I was going to use you know, the Atmega chip, but for the amount of hassle that I'm going through to get that to work, Pro Minis cost like $4 each on eBay, so I can't really, you know. And if I use this, I'm losing 2 analog inputs, which I use every single input on these chips. So I'm going to have to save this for another day, another project, something else. So I'm going to be getting some Pro Minis in the morning. So you can see that light is pretty bright. And right now this works. This is the system that I know works, this particular Arduino. And so I have everything hooked up, or most things hooked up. What I've discovered is that using the same rail type system I was using before, where I, you know, connect the circuit with that, with one of these conductive pieces, pressure sensitivity is okay. It's not bad. I had to put resistors in, so you can see those. See? So I had to stick. Luckily I have a light there now so that you can see everything, but I had to put resistors in on all the circuits because it was not trying to hear it otherwise. I thought that the material would be resistant enough, but it isn't. And when I tried to do it directly, it just shut the whole system off. So so now every one of these has its own resistor. Now these, the ones with the green wires, these are switches. I've discovered that while this conductive material makes beautiful sensors, and I can see myself growing into this over time. It makes shitty switches. It doesn't make a good switch at all. There's no way to because what I need is a digital high, which means that it goes from 0 to 1. But the thing that makes it such a good sensor is that the pressure sensitivity means that it'll be somewhere between 0 and 1, with a varying degree of resistance based on how hard you press. So I press these hard, and I get more resistance, and I'm getting a stronger signal. But no matter how hard I press these, I'm not getting up to digital 1. So I'm making some new sensors that'll go in there that will have wire wrapped around them, so that they make a proper sensor while still being able to slot into these little slots that I've made that I like so much. Okay, so this is my solution. See, so I'm going to solder to that edge, and then that'll make the switches that'll kind of replace the ones over here in this area. These all have to be switches instead of just sensors. So these are going to be my sensors. So I'm going to make these, and then I'm going to put them in. Okay, so now now you can see those are copper. So now when I bridge these across there, when I bridge those are going to make a switch. So I'm going to bridge those with a piece of wire. So this will make a switch, and then I can kind of design into that switch, because it's going to be Ninja Flex that's going to kind of fold out of there on a flexible piece. I can design the amount of pressure that's necessary to trigger it, so it's just not accidentally triggering. So maybe basically I can embed it into the Ninja Flex just a little bit, so that if it's just touching, it's not. If my thumb is touching it, it's not actually triggering it. But if I press a little bit, that wire just kind of comes poking out, and it triggers the thing. And it's going to be a very thin thing. It's only going to be that sliver in each of those directions. And it's the same thing here, up here and there. And this is going to get replaced next, but that one's a little bit more complicated, so I'm saving that one because I'm printing something else right now, which is going to put the thumb in a better position. Okay, so now it's assembled. Yay! So that's what it looks like without the shell. There's going to be a shell. I have the battery. I don't have an on-off switch yet because I'm designing that too. I want to be able to turn off the Arduino, or turn off the Wi-Fi, or charge the battery later. But right now I just want it to work. So you can see there's the ESP. Let me put this down for a moment. So there's the ESP. I'm going to put a capacitor on that so that it's getting smooth data. This is one of the Pro Minis. You can see it just kind of fits in that pocket. Even though it looks like a lot of wire, it's a lot less wire than it was. And the wire was kind of necessary because the conductive material was not doing it with using it as a wire in the context I needed. I need high voltages, and I need them to be predictable. And conductive material is good for pressure sensing, which makes it shitty for circuit making. I can actually turn. The thing that's interesting is that the lights have a common anode instead of a common cathode. If they have a common cathode, what happens is that when you turn it on, that common cathode gets the negative hits that LED and it turns them off. But when you have a common anode, the exact opposite happens. So you turn it on, you can see the ESPs and the other one coming on, and then boom, and these lights are bright. So you can see just how bright they are. So let's look at it in the mirror. you can see even in daylight these things are blazing, and it gives a bit of extra context to the angular motion. So you see right here, so the accelerometer is right there above, in between where the index finger and the thumb are. So it's in that pinch zone. So I still have that pinch zone thing that I liked from before, but now I've got much more realistic relationships between all the fingers and the thumb. It's beautiful now, the layout. Right now the Wi-Fi part is not working. I tested it with the other Arduino to make sure that that everything did work. So I know that the system is wired right, but this relationship right here I don't have yet. So I'm going to do that, make the cover, make the key thingies, and make sure that everything works. And then I'm going to start directly, well, I'm already printing parts for the right hand, so I'll start assembling that. It'll also give me an idea of how quickly it can be done. Since I know how to do it, I can get an idea of its workshop potential. And then make a new mouth interface, which is actually the easiest thing to do, and get all of this working, so get all of this assembled, so that all I have to think about tomorrow evening and Thursday and early Friday is getting the Wi-Fi to communicate with the router and the Arduino. Okay, so this is the cover. This is going to go on top of baby here. I don't know, I actually like it without the shell on it, but I do want it to be a little bit cleaner. It's the ESP that I have yet to be able to program, the accelerometer. And this is the right hand, so you can see. Da, da.